Yep. So we are recording here. So we're going to talk about chapter 11 here. So the first thing we're going to talk about here in chapter 11, let me share my screen here so you guys can see what I want to show it to you. So chapter 11 is called a goodness of fit and a contingency table. So what we're going to do here in chapter 11, you will learn a new distribution. It's called a chi-square distribution. Last time in the chapter 9 and chapter 8, you guys do Z, which is a standard normal distribution. And you also do the T distribution, the student T distribution. So this time we will have what we call as a chi-square distribution. So, so when you have a chi-square distribution, it is a little bit different from Z or T. A chi-square distribution is actually skewed to the right. So that means that usually a T or a Z distribution is a normal distribution. So not symmetrical, normal and symmetrical, but for a chi-square distribution is skewed to the right. A chi-square distribution can only take values that is 0 or positive. It means that if you draw the picture, the smallest number you can have is 0. And then the highest number that you have is a positive number. That means that this chi-square distribution did not go to the negative values of Z, of the value of the value of the chi-square. So that's mean that when you do your test statistic, your answer is going to be positive. Okay, cannot be negative. The degree of freedom. So the chi-square distribution has a degree of freedom of k minus 1. Where k in this case is usually number of categories. There will be your R will give you the degree of freedom if you use the if you type I'll show it to you today what it looks like. And then what if your degree of freedom keep on increasing? That means it's getting bigger and bigger. It will approach normal distribution. So if you want to look at a picture of a chi-square distribution, this is found in page 333 in your textbook. So this is where's the textbook? There you go. So this is a chi-square distribution here. The formula looks something like this. So you do not need to worry about your formula for chi-square distribution. Then what we talk about here is that your degree of freedom is n minus 1, and your chi-square distribution is skewed to the right, not normal. And then your value for chi-square is either 0 or positive numbers. And then as your degree of freedom is increasing, your chi-square distribution will approximately normal. So this is what it looks like as a chi-square distribution, the yellow one. So it is skewed to the right. It's not symmetrical. And you notice that when you look at your chi-square distribution here, all these values down here are non-negative values, means that you can not be negative. You can have 0 or positive. So when you do your test statistic, your critical value, they are all, this is called test statistic or critical value, is all inside this value here. They all will be positive in this case. This is what happens when your degree of freedom of 10, you will get a very skewed chi-square distribution. When you have a degree of freedom of 20, the skewness will approximately normal. So if your degree of freedom keep on increasing, then this distribution will end up to be a normal distribution. Okay, so this is the chi-square distribution that we learn in that you will learn in this chapter. So this is all about chapter 11. Okay, so at chapter 11 we got 2 types of stuff. One is called a goodness of fit test, and then one is called a test of independence, and then we have a test of homogeneity. So actually there are 3. So what is the difference between a goodness of fit test and then test of independence and test of homogeneity? Goodness of fit test, you only have what we call as a 1 variable in this case, a 1 categorical variable. Okay, so a goodness of fit test is only used for 1 categorical variable that is in a table form. Okay. So, so this is a goodness fit test is usually given in that case. So the reason I'm showing you all this is because your test, when you do your test and your final, everything is being jumbled up. So you need to know which one is which. So like chapter 10 is very straightforward type. Chapter 10 is talking about regression and correlation. So every time when you do my test, when you ask for, give me the regression line, give me the correlation R and all these things, then we know that is chapter 10. I mean, for sure, okay? For this case, how do we know this is a goodness of chapter 11 is a categorical variable, and you only have one in this case, okay? So these are the notations that you have for goodness of fit test here. The O is the observed frequency. Observed frequency is usually given in the data or you collect it. So let's say example here is if you collect data from your project. So I got the students did a project on data regarding with, oh my God, this doesn't let me. What happens to my work? Seems like it's not working. All right, we'll figure out. Probably use Notepad. So some students collect data. They use what we call as a one frequency distribution, and they will look something like this when you collect data. They look like if you open a bag of candies, M&Ms in this case, and you start to count how many are green, how many are red, how many are so on. So you count all this up, and then the observe is the count. So how many red candies you have, how many. So that is what we call as an observed frequency, and usually is given in the data, in your data, or you collect yourself, and your observed frequency has to be a whole number, okay? Expected frequency is a frequency that you expected. So like expected means the expectation. So you kind of expected how many red do we have when you open a bag of candies, how many green, that is what we call as expected frequency. And usually this expected frequency, we have a formula to find it, is N times P. N is your sample size, P is your probability. And your answer has to be in decimal. So the expected frequency, usually the answer is in decimal. Sometimes it can be a whole number, sometimes with decimal, which is fine. But your observed frequency has to be a whole number. And then K in this case is a number of categories. So how many categories do we have? So how many M&M's colors do we have? I think we got 6 colors, right? So if you have 6 colors, then you have 6 categories in this case. N is your sample size, and P in this case is your probability. I just want to point out to you that when you guys do a goodness of fit test, you always do a right tilt test. So all your chi-square distribution is always a skew to the right. So when you skew to the right, it is a right tilt test in this case. So you will do what we, in order for you to find the critical value. So this is something that you need to watch out, because in this chapter 11, I do ask for critical value. So if you want to find a critical value, you use the Q chi-square 1 minus alpha K minus 1. So this is the one that you have to type in R to find your critical value. Alpha is a level of significance. K in this case is your number of categories. So don't forget, this is your degree of freedom, okay? Requirements, it has to be randomly selected, which is everyone, you have the SRS, first requirement. Second requirement is frequency count for each has a different categories. What do you mean by frequency count for each? The data consists of frequency count for each of different categories. For example, is like what we just did, the M&Ms here. So the M&Ms, we got red, orange, yellow, brown, blue, and green. So they all have their frequency count, the 13, 25. That means you count how many in each color. We don't do like purple, or we don't do black, or we don't do, I don't know, pink. The reason why is we don't put all those colors in, because we don't have such colors for M&Ms, for the regular M&Ms that we have. So that's why we don't include those colors. So that's that is the meaning of the second requirement. Second requirement means that every category must have a number belongs to it. So that's why for the M&M case, we don't use pink or purple or black, or the colors that we have, white or whatever colors. So because we don't have a frequency count for those cases, okay? And then lastly, expected frequency is at least 5. So I want to point out to you guys that your R programming did not find expected frequency. You have to find it yourself. So when you guys do do it in your R, you have to find your expected frequency, and it's not that difficult. You just take N times P, and this expected frequency has to be at least 5 for each category. So I will show to you what does that mean by that, okay? Your hypothesis statement, this time you only got your now is either the frequency count agree, your now alternative is your frequency counts do not agree. So for hypothesis statement, in this case, you only get two types of hypothesis. That means it is either equal, this is for equal, and this is not equal. So you don't do less than or greater than for chapter 11. So chapter 11, when you do a chi-square distribution, it's either equal or not equal. You don't have other alternative, like last time we do less than, greater than, right? We don't have that anymore. Okay, and then this is a formula to find your test statistic. So if you are doing using your textbook where they ask you how to find test statistic, this is how you figure out. They use a table, but as long as we put this in your R, we will able to find a test statistic without doing any work for without doing this formula. First, you need to in your R, you have to give me your counts. Your counts in this case is your observed frequency. Okay, your count in this case is your observed frequency, and then the probability in this case is the probability for this case, so P in this case. So make sure that your counts and the probabilities have the exact same amount. That means if you have 10 counts, then you should have 10 probabilities. This probably can be equal. Equal means that they're all the same. For example, is if you look at rolling a dice, if you roll a dice, what's the probability you get a 1?
1/6.
1/6. So that means you put 1/6. Probably you're getting 2.
Same.
Same. So that means this probability for the example I give to you are equally likely. So so you got 1/6, 1/6, 1/6, 1/6, 6 times. And then the counts is that you start to take a dice and you start to roll it like, I don't know, 500 times. And you record how many times out of the 500 times came out 1. Let's say 80. So you put 80 on this, that's your count. And then how many of them came out 2? 50. How many came out 3? You know, you just record all those. And then you put 1/6 because the probability of getting 6 is 1/6, 5 is 1/6. So, and then you do a chi-square dot test, make sure there's a period right there. Counts, comma, P equals to prop. So this is, and then they will give you the test statistic. They will give you the p-value, and they will give you the degree of freedom. And then after that, you just do the you can use that to find your critical value. So as usual, when you guys do your hypothesis testing, if your p-value is less than alpha, what do you say when your p-value is less than alpha? We reject or fail to reject H0?
Reject it.
Reject. So if your p-value is less than alpha, we reject H0, right? So reject H0 means you're rejecting him, so you are taking your H1. So if your p-value is less than alpha, then your conclusion will say the counts do not agree with the claim. Okay, I'm going to put equal to because it can be less than or equal to. What happens if your p-value is greater than alpha? Then we fail to reject H0, right?
Yes.
So that means that if you make this conclusion, if you have this decision, then your conclusion will be saying that it's agree with the claim distribution. So this is what happens when you guys have your decision, because you guys know this decision, right? The p-value less than or greater than. Now you use the so every time when you make a decision, when you have when you reject, you have what? There is sufficient evidence, right? Sufficient evidence, cannot spell today. You have to use the word warrant rejection in this case, okay? So when you do your chapter 11, because we don't have less than, we don't have greater than, we have a not equal to, so the warrant rejection has to use here. So again, when you reject, that is sufficient. When you fail to reject, that is not a sufficient, right? So make sure you guys know when do you use sufficient and not sufficient, and based on your decision here. And usually your conclusion is right, your claim statement is either one of those. Okay, so let's take a look at some example on your homework here. So this is 11.1, question 5. So this table below shows a list of frequency for the different poles of horse racing. The position of 1 is the closest inside rail to the shortest distance run. And then there are 10 positions here. Use a 0.05 significant level to test that the claim of the likelihood, this is your claim, of winning is the same as a different position. Based on the result, should batters consider post position of a horse race? So this is for those who want to go gambling on the horse racing. So this question is asking, are they the same? So your hypothesis in this case is at least one position have a different frequency. So if you look at your hypothesis testing in this case, your frequency count to be agree with the claim distribution. So when I say claim distribution means they have to be in this case, the same. So at least one post position have a different frequency, not different. They'll have a different post, equal frequency. Yep. So this should be wins occurs with equal frequency in each different position. So it has to be equal, not different position. At least one. I don't have the word at least one. So this should be win frequency should be at least. Then the alternative is at least one of the position have a different win with the others. What's the difference between these two? At least one post position has a different. I think it's this one because it's a grammar mistake.
I didn't see the difference either.
There is a grammar mistake here. They just use at least one post positions. They have a plural have. It's just a grammar mistake. But I want to point out to you guys that your online homework shows something like this. But when you do your test, you just say HO is the frequency counts agree and H1 is frequency counts does not agree.
Okay.
So you do not need to do like what your online homework says that HO is wins occur at least one. You do not need to do it. You just say one is agree with the claim and the other one is does not agree. So it's very straightforward in your test. So you do not need to do something like this in your test. Okay, your homework is just a bit special. Yeah, the other one is they have a positions have. So it's a kind of it's a plural. So it's only one. So you only have singular. So next we have to find the test statistic in this case. So in order for us to find the test statistic, you have to get all this to put under counts. Okay, so you have your R. So once you have your R, so you begin to do your counts here. Then you have to type all these numbers inside. I recommend you to type. So don't copy and paste and don't import it to the table into the notepad. So I recommend you, it's only 10 numbers, it's not really much. Okay. Someone said something in the chat. Someone mentioned something. What is the importance of expected value? The importance of expected value is to do the requirement number 3. Because the third requirement says that your expected frequency has to be at least 5. So this is what the importance of finding the expected frequency is because of requirement number 3. Okay, so that's why we need to do that for that case. So so in this case, let's put this in your R. Got sidetracked. So 18 is the first one, 13 is the next one, 10 is the next, 14, 7, 8. You can space or not space, it's up to you. 13, 5, and is that 11 is the last one? That looks like 11 is the last one. Okay, so this is your counts, and then you do prop. So prop in this case is the probability. So so prop C, so it's a probability. So so we will do the probability in this case. Since this question does not provide us any percentages or any probability, that means what's the probability that the first position will win? So that means we treated this all equal winning in this case. Okay, so equal means because there are 10 positions here, So that means this is going to be 1 out of 10. So every single one of this, you have to do 1 out of 10. And yes, you have to type this 10 times. This is like a probability. Okay. Or if you want, you can put 0.1, which is the same thing as 1 out of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. And then you do to find that, you do the chi-square test counts p-prop. Okay, P equals prop. So you do the chi-square test, exactly the same, counts, comma, p equals to prop. So there's no, you don't do BSD or something else like that. So this is your, so once you type this, if you get your answer like this, that means it's good. If an error came out that is a mismatch, means that you have entered something wrong in your data. That means you entered 10 numbers in counts, but you only enter 9 numbers or 8 numbers or 11 numbers in prop. So that means if you have 10, you should have 10, then you will get your answer. If you have a 10, but you enter only 9 on the other one, or 8 or something that's not matched with the counts, then you have what we call as mismatched dimension, and that's where the error message came out. Okay, so the chi-square here is your test statistic in this case. So some of you will ask me what is a test statistic in this case. It's written down here. So in 3 decimal place is 12.044. But that's your chi-square. DF is a degree of freedom. So some of you will ask me what is a degree of freedom. This is a degree of freedom. And your p-value in this case is 0.2108, exactly 4 decimal place. So you don't have to round anything. And then, so now the p-value that we have is less than or greater than alpha. This p-value, the alpha is 0.05. So your p-value is what?
Greater.
Greater. So we will reject or fail to reject.
Fail.
Fail to reject. Now, when I did grade your test last time, make sure you put fail to reject H0. A lot of students just put fail to reject. So if you just put fail to reject, it can fail to reject H1. So that's why I will take points off in your test, in your future test. So make sure you put either reject H0 and fail to reject H0. So the H0 at the back is very important. If you did not do this in your future test, I will take points off. So it's either A or B. So when you fail to reject, is there is or there is not sufficient evidence?
A.
There will be not sufficient evidence to warrant rejection. So I can tell you that the whole chapter 11, you have to use the warrant rejection. And then these are the same. So which is the same thing as your claim statements. So this is how we do this. Now, you notice that based on which should better consider post position of horse rating. So when you say this, it is not sufficient up to warrant rejection. So the word not and warrant rejection will cancel out, means that what? The likelihood of winning is the same as different position. So this is a conclusion you make. Again, insufficient and warrant is 2 negation. You can cancel it. So what do you mean by likelihood of the winning is the same in a different position? Means that no matter you pick which position, the winning is the same. So people think that because you are in the first position, it's inside. So that means they run fast, they'll win. And those who are in position 10, which is the further away, will not win a lot. But based on these results, actually should better consider post in the case is no. Okay, because the results are the same in this case. So the position of a horse race does not tell you who will win in this case. Okay.
Is that because the chi-squared is not as sensitive, that a more sensitive test might tell you to bet on position 1?
No, this is not based on the chi-square. This is based on your conclusion that you find.
Okay.
So this conclusion say that, because if that means what happened is then if position is considered a bad a position of a horse is a good bet, then if it's that true, then I always go for the first position, because the first position is always a winning horse. You know what I mean? I wouldn't bet the 10th position, because the 10th position is a losing horse, because 10 is the most further away from the distance. You know what I'm talking about?
Yeah.
But in this case, based on the conclusion that you have, you say that they are the same. okay? But if your answer is in rejection, so if your answer is C, there is sufficient evidence to claim this, then your answer will be yes. That means the first horse will always win, the second horse will be the second place, the third position horse will be third place, and the last position will be last place. If your answer is C. So it all depends on your results and everything.
On the Pearson video where he had a die that he put a weight in and he rolled it 200 times and did a chi-squared, he said something about it not being sensitive enough that he knew it was a weighted dice, but the chi-squared didn't prove it.
Oh, I think it's because maybe I do not know. I think it's maybe 200 is not big enough then.
Okay. Yeah,
he might have to roll 2,000 times or 5,000 times. So yeah, so it depends. I mean, it depends on. I think 200 depends on the outcome. In this case, it's really weird. Some chi-square is a good test actually to do this. But I will recommend you to I think 200. Sometimes if you find out that your chi-square is not working well, then you might have to increase it to more sample size. Means like 500 or 1,000 times.
Gotcha.
But usually it's good. I don't know why that the author give that word. All right. So this question is also goodness of fit test. So this is actually a table below is the best of 7 baseball champion series. The expected proportion is the number of games played that has equal abilities. So this time they give us the expected proportion. This expected proportion is your probability. Okay. And then you say use a 5% significant to test the claim that the actual number of games fit the distribution indicates in the expected proportion. Also, by the way, if you look at this chapter 11, do we do anything with confidence interval?
No.
No, you're correct. So we do not, the whole chapter 11, you don't do confidence interval. So you don't do the 95% or 98% confidence level. In this case, we only do hypothesis testing here. Okay. So so what is your hypothesis in this case is again at least one agree with 2 or the expected agree with should be agree. So make sure that in this case observed frequency agree with the expected proportion. So this is what we have on your agree. Okay, make sure that. So this is a kind of a keyword I'm looking for is agree and does not agree. So that's the keyword I'm looking for in this case. And then this one will be at least one of these does not agree. So agree and does not agree. Okay. So usually this is what happens to the to your hypothesis statement. The keyword here is agree and does not agree. That's it. Okay. So when you do your project, if your project is about goodness of fit test, same thing, agree, not agree. Okay. This question now I need to show it to you how you find your expected frequency. Okay. So some of you guys need to know how to find your expected frequency. So the first thing you need to know when you find because this question, your online homework, they didn't go through the first step, which is to check your requirements. But in your test, I do want you to check your requirements. So as you know, it is randomly selected. These are pretty straightforward. But the third requirement says your expected frequency has to be at least 5. So how do we know this expected frequency is at least 5? I'm gonna my notepad. I know something wrong with my word today. I don't know what happens. So let's take a look at your expected frequency in this case. So what you do first thing is figure out what is your sample size. So how do we figure the sample size is you add all these numbers. You add all the actual contests. That is your N. So 16 plus 19 plus 24. If you have a calculator, use your calculator. 36. So that is 95. So we have 95 total. So if you want to do the first one where the game number here is play by 4. So play is 4. We got 5, we got 6, and we got 7. So how do you find the expected one? So in order for us to find the expected, you take the expected proportion times with your sample size. So you take 2 over 16 times with 95. So this is gonna be 11.875. This is your how you figure out your expected frequency in this case. And then the next one, you take 4/16 times 95, which is 23 points. So this is 23.7. So you guys know how to do this now? It's not that difficult, right? 5/16 times 95. This is the third one. So this is 29.6875, and then this one is 29.6075. The reason it's the same is because your expected proportion is the same. So do you guys know what happens when you add all these numbers up? What do you get?
100.
Not 100.
No?
No, not 100. No. 11.875 plus 23.75 plus 29.6875 plus 29.6875. Anyone know what is that? You get exactly your N95.
Oh, okay.
So your expected frequency total should be the same thing as your actual frequency total. And do you know what happens when you add all this proportion up?
That would be 1.
That would be 1 or 100%, 16/16. Yes. So this is expected frequency. So the requirement says what? That your expected frequency has to be what? At least 5. So you look at all these numbers, at least 5. The one we just expected frequency. Yes, all of this number is at least means 5 or more. So they are all 5 or more. So in this case, it fulfills the requirements here, the third requirement. So this is how you find your expected frequency. And yes, I will ask that in your test. So make sure you guys know how to do this. So how do we do this question in your OFF to find your test statistic here? Is we do the same thing as last time. You do the counts. Caps here. Counts equals to C. And then you do 16, 19, 24, 36. And then now your prop in this case is gonna be your expected proportion, which is 2 out of 16, 4 out of 16, 5 out of 16, and 5 out of 16. I will recommend you to give your answer in fraction. So don't use your calculator and find, oh, 2 out of 16 is point whatever you put in there. If you do that, your answer will be wrong, because if you want to put 2 out of 16, what is 2 out of 16 is? 2 out of 16. If you want to put 0.1, okay, this is fine. But if you put 0.13, if you put 0.13 in the first one, then everything you calculate in your chi-square is wrong. So I would recommend you to use a fraction if it's given fraction. If they give you in percent, then you put it in decimals, okay? And then you do the, once you do this, and then you do the chi-square test, then your test statistic in this case will be 4.815 in 3 decimal place. And your p-value is 0.1859, sorry, that's 4 decimal place. And then, so then you do the conclusion, which I think you guys know. Sometimes a question wants you to find your critical value. So this is how you find your critical value. To find your critical value is Q chi-square 1 minus alpha K minus 1. So if you want to find the critical value in this case, I just short form to CV. Okay, critical value is you have to do Q chi-square. Now your alpha in this case is your alpha here. So your alpha is how many percent? 5%, 0.05. And what is your K minus 1? Your K minus 1 is your degree of freedom. In this case, is 3. So if you want to find what is your degree of your critical value, you do the Q chi-square 1 minus 0.05, which is your alpha. And then whatever you calculate on early on, the DF, you see 3, you just put 3. That's your degree of freedom. So that 7.18 is your critical value. You guys with me here?
Yes.
Okay. So in your test, I will ask you to find the expected value also. And I also want you to find the critical value. So make sure you guys know how to find this on top of doing all these things you see in your homework here.
If our expected is less than 5, do we just stop?
No, if your expected frequency is less than 5, means that your third condition does not, your third requirement does not fulfill. But as you guys know that this is your test. This question worth around 10 points. So you still have to continue.
Okay.
But in the real world, when you do your project for your company, or you're doing your research for your company, then yes, you stop. But for this class, you will still have to continue with the rest of your work. You have to do the rest of this, although your requirements does not met here.
So make note that the requirement isn't met, but then continue the problem?
Yeah, the
Gotcha.
whole time, because you haven't learned, you are scratching the surface for statistics. You haven't learned what's going on if one of these requirements does not met. Yeah, so the statistics will branch out if your requirements does not met. So in this case, for all your, I don't care, it's chapter 7, chapter 8, chapter 9, whatever chapter you have, if your requirements does not met, you will still continue working on it with the distribution that you use.
Okay.
Like your binomial distribution. If you did not fulfill your binomial distribution, you're still gonna continue with the binomial distribution in this case. Otherwise, you will lose a lot of points in your test.
Okay.
In your test, you have to continue working on. So this is 11.1. So it's pretty straightforward type question. So it's not that difficult. I mean, it's just following what we have here. There are some questions in 11. Anyone have any questions before I continue with 11.2? This is goodness of fit test. This is pretty much very simple. Let me just exit out. This is meeting. So we're going to talk about 11.2 now. So 11.2 is talking about tests of independence and tests for homogeneity. So we call it contingency table. So what is the difference between 11.1 and 11.2? 11.1 is called a goodness of fit test. We only have one categorical variable, but 11.2 is a contingency tables. Now we will use two categorical variables. So last time, if you look at the example that we have, you only have one type, one categorical variables, okay? And then this is just observed and expected. But in this 11.2, you got two types. You got the type that, you got two types of category. One is on here and the other one is on here. So you got two types of categorical. So this is what we call as a contingency table. That means that this number belongs to male, white male. This number belongs to white female. This number belongs to black male. This number belongs to black female, and so on, so on. So once you put into, if you can categorize in two category, then we do contingency tables in this case. So you guys know the difference between goodness of fit test and contingency table? Because you guys need to know this before you guys know to do your test, because your test is all jumbled up. You need to know, really important. And when you do contingency table, we got two types of tests: test of independence and test of homogeneity. Okay, test of independence is very straightforward. It's telling us that is these two rows are independent or not. Okay, and test for homogeneity is telling us that are this proportion, these numbers here, are they the same? So if you want to compare male and female, you want to see if the male for this race, are they the same for the female? So that is what we call as a test of homogeneity. So one is independence, test them they're independent, and one they say they have the same proportion. So when you do your test is a very clearly stated. They will use the word independent if you want to test for independent, and they will use the word same proportion. If you use the word same proportion, then it's test of homogeneity. So, so it's very straightforward type in your test. So either you will see in the question, either you see the word independent or you see the word same proportion. Okay. So if it's independence, no matter it's independence or homogeneity, your test is identically the same. Okay. So if you look at here, Conducting the test for homogeneity is the same as conducting the test for for independence. The only difference here is your hypothesis statement is written down differently. So if you are doing tests of homogeneity and tests of independence, they are the same test, except your HO and H1 is different. That's it. Okay. As usual, this is O and E, which is observed and expected frequency. R in this case is your number of categories in the row. So don't forget, this is called row. Row goes left and right. So how many rows do we have here in this contingency table? How many rows we have?
Only 2.
No, rows. This
is it all 3 then? Okay.
There
I'm
is
looking at the nicotine problem.
5. No, this is 1. I'm talking about this one. This is 5 rows, right?
I see. Okay.
And how many columns do we have?
2.
2. So in this case, R is the number of categories in a row, so that means it's 5. C in this case is number of categories in a column. In this case, it's 2. It's kind of straightforward type. So make sure you guys know which is row and which is column. And class, if you flip these two around, you might have a little bit trouble. So try your best to know which one is row, which one is column. Requirements, it has to be symptom random sample, it has to be two-way tables, and your expected frequency has to be at least 5. So kind of very similar to what we did in goodness of fit test. The only thing about goodness of fit test, we don't have a two-way table, we got one table. We got just a normal table in this case, okay? So, but the rest is the same. This is your hypothesis statement. If you want to test for independence, you just say the row and columns are independent. The row and column is dependent. So this is how you do your null and alternative hypothesis. So again, when you have p-values, it's the same decision that you guys do. I told you, if you know your decision and conclusion, in chapter 8, chapter 9, same thing, 11, same thing in 12, no change, okay? So how do you find your expected frequency? So now you have to take the row total times the column total divided by grand total. So it's a bit more work here. Is why I say you need more work is because you have to figure out your total first. So you have to add all this, so you get 69. You have to add all this, you get 53. So this is what we call as your column total. And then you add across 30 plus 21, this is 51, and then you add across. So all this is what we call as your row total. And then you add these two up, which is 122, or if you want to add all this up, it's also 122. So that is your grand total. So if you want to find the expected frequency for male white, you take the total of 69 times a total of 51, because it's male white, 69 times 51 divided by 122. So in this case, you take 69 times 51 divided by 122. So that number is the expected frequency for male white. So in this case, you have to do 10 of this. So this is for male white, then you have to do the female who is white. So in this case, the female in this case is 53 total, times white is 51, divided by the grand total 122. So this is the expected frequency for the female white. And you have to repeat the same thing for the black, I think it's Asian, Hispanic, and none. So there are so many groups there. So you have to, like black case, black male, you have to take 69 because it's male, times with 36, that is the black, and then over by your grand total. So this is expected frequency for this is 20.36. So you have to do all this work to find this expected frequency. And why you need to do this is because of the third requirement, because the third requirement says that what? All these numbers should be what? At least 5. So by looking at this, yeah, all these numbers that you calculate here, they're all at least 5. So you have to keep on doing it until maybe the none case might be a problem because that is small. 69 times 5 divided by 122. Okay, that's a problem now because 69 times 5 for the none case, 5 times divided by 1 is only 3, which is less than 5. So for if you have this contingency table, requirement number 3 does not match here. So this does not match, no good. And the reason why it does not match for this case is because we recalculate that this is no good because it's small. So do you still want to continue with the hypothesis testing here, class?
For the test, yes.
Yes, but for if you're working in your project for your company or for your whatever, the big, then the answer is no, you stop. That is, you have to go on to chapter 13 in this case. We do not do chapter 13 because we're running out of time. So chapter 12 is the last thing we do here, okay? And then the degree of freedom is R minus 1 times C minus 1. So what is R minus 1 is you take the row 5 minus 1, that is 4. And then C minus 1 is a column. We got 2 minus 1, so it's 1. So you just take 4 times 1, that is 4. So that is your degree of freedom. That is used to find your critical value. Again, it's the same thing, 1 minus alpha with the degree of freedom. In this case, 4. Okay. Then this is how you guys have to do in your R here, is you have to begin to write X in a matrix form. So how do you do X in the matrix form? Is you have to do X equals to matrix C. This number is your observed frequency, and how do you read it? You have to read it downwards. So what I mean here is you have to read, if you want to put this number, I have to put 30, 21, 8, 7, 3. And then back up north, up 21, 15, 10, 5, 2. So you have to read your data, your observed frequency from up to bottom, and then go to the next line. So if you read across, you will get everything wrong. Okay, so this is something I want to point out to you guys, very important. You have to read downwards, not across. And then the NCOR means how many columns do we have? So in this case, we got 2 columns. So NCOR is 2. And then you do a chi-square test, X correct false. So you do not need to do anything that I just written down here. So all these things I scratch off, please scratch it off. It's optional, so you do not need to do that. I also recommend you to type X out before you do the chi-square test. When you type X out, it shows you all this number in a matrix form. So you have to be identically the same. Okay. So let me do this. And then when you do test for homogeneity, it's exactly the same test. The only thing here is your H, your null, and your alternative hypothesis is different. One it says they have a same proportion. One is using different proportion, or sometimes we use not the same proportion. So no matter which one you use, same proportion, different proportion or not the same proportion, they are the same. Okay, so doesn't matter here. So let's take a look at your homework in 11.2. Continuity table in this case. Again, you don't have a lot of questions to do because these are very straightforward type questions. I think you got like what, 11 questions per sections, right? So it's not that difficult actually for chapter 11. But some of your projects, you will have to do this section, especially those who collect data from the students. Okay, you go out and do a survey. And then once you do a survey, you manage to put it in the form of this contingency table, then you're definitely doing this section 11 too. Okay, so this is a table. See, this we got this table. So many people believe that a criminal who pled guilty tends to get a lighter sentence for those who are convicted the trial. So the company table is randomly selected by different select data for defendants in burglary cases, and all have prior sentence. So guilty, sent to prison 423, not guilty, sent to prison is 56, and then so on. So this is the table here. So test the claim that sentences sent to prison is independent. So this is an independent case for this case. And then, so which one should we pick for our hypothesis statements in this case? A, B, C, or D?
I think D, but I can't see it anymore.
You can't see it?
On your screen, I can't. I did this problem myself.
Oh. So it has to be one is independent and one is dependent. So this is wrong because it's been switched. A has been switched around. No, it doesn't say anything about independent, dependent. So in this case, it's D in this case. It should be dependent and not independent. Okay. And then you have to find the chi-square. So in order for us to find the chi-square, you have to use your R here. So, so how do you use our R here is we have to build a matrix. So X equals to matrix. I think that's I think it's matrix. Yeah. X equals to matrix. Yep. And then C. And then you have to use the number. So the number that we have here is, again, you have to use up and going up to bottom and then move on. So the first number we have is 423. And then you go down to 576, and then 56, and then 30. And then put a comma, and then N core. N core means how many columns we have. So in this case, we got 2 columns. Okay. And then when you hit enter, you hit X enter, and make sure that this matrix that you form exactly looks like your table, exactly the same numbers and everything. Because if this matrix you formed is different from here, you will get it wrong no matter how you do it. Okay, so make sure you know how to do this. It's very important. And then you type chi-square dot test. No dot here. So chi-square dot test x comma correct equals to false. The reason why they use the correct equals to false is for some requirements. So that's why we have to put that in there. Otherwise, you get the wrong answer here. So in this case, your chi-square is in 3 decimal place is 16.656. And your p-value in this case, this means it's very, very small. So it's 0. So if you want to write this, this is 0.000404482. So this is the meaning of this p-value. But in 4 decimal place, it's still going to be 0 because it's too small. Okay. And then, so your p-value is small. So what you conclude? This number is what? Less than him, right? So if this p-value is less than your alpha, what can you conclude here? That what's your decision? P-value less than alpha. You reject or fail to reject?
Reject.
You reject, and when you reject, that is sufficient or that is not sufficient? That is sufficient. So your answer is either A or B. That is sufficient in this case. They're exactly the same. There is sufficient evidence to warrant the claim that a sentence is independent. Okay. So the result encourage plea for guilty defendants or do not encourage result. So since they are, you say they are not, they are warrant rejection. So when you say warrant rejection means that you are rejecting H0 means that what they are depending. So depending means that those people who are guilty or not guilty, it depends on they sent to prison or not. So does that encourage the plea for guilty or does that not encourage pleas for guilty defendants? So it's encouraging people. Every time when we find out this is too depending means I think it's, let me see, I think it's the other one. Okay, this one. So mostly what I want to tell you here is in your test, we don't talk about that. We always talk about what we call as effects. We always talk about effects. So in your in your test, usually we'll ask you for, does this have an effect on it? So the question is, if you say that this is you fail to reject, your answer will be no effect. Okay. So when you fail to reject, you have no effect. If you reject, then that is an effect of it. Okay. So usually in your test, I will ask you, does that affect or effect something happens? So your answer is if you reject, that's the effect. I think that's why that question is positive in this case, is affecting for that case. So Mostly for this case, like here, it's also test for independent. So it's pretty straightforward type. So again, this is the same type of questions here. I'm gonna try to see if there is one that is showing another one. No, this is multiple choice. No. Where's the other one? So I need to show you. Oh, there you go. So if there is a calculator came out like this or whatever the results, you do not need to use R to do it, because the P you see here is your P value. So if any have a result came out, you didn't use R. So my question is, this P value, is that less than or greater than your alpha?
Greater.
Greater, so we will reject or fail to reject if it's greater. We will fail to reject, right? So once you fail to reject, so if you remember what I showed to you last time, that is not effective. So in this case, this is usually does not dependent. Fail to reject, yep. Let me see, this one you have to think about it. You fail to reject of this, so this should be dependent. Yeah, depend, because you fail is negation. Independent, that means not independent. Not independent means it's dependent in this case. No, maybe not. That does not depend. Okay, so yep. So I just want to point out to you that when you have failed to reject, your answer here is always says not. And when you have reject, your answer is yes. Okay. So this is how we do this kind of questions in your homework here. So does anyone have any questions for me before we end the Zoom session here? One thing I want to point out to you guys is your project. Because this week you should go through chapter 12, which is the last chapter we go over. So I want to point out to you that oh, this one is let's do this one first. Let me talk about the project first, and then we can. So what happened is that, where's my chat? I missed my chat here. Okay, let me stop sharing here, and I will go back to the other one. So first thing is, so chapter 12 is your last chapter. So you don't have 13 to do. And then 12 have 12.1 and 12.2. And some of your project will need chapter 12. I can tell you that when I look through your project. There are some of you guys require chapter 12 to do your project. So chapter 12, so what happened is that your test 3, which is your last test before your finals, will be given to you on next Tuesday. What is that day? I think it's May 5th, right? So test 3 is going to be on this coming next week Tuesday. It will cover chapter 10, 11, and 12. So that test 3 will cover chapter 10, 11, 12. It's the same thing. You got around 13 to 14 MCQ, multiple choice question, and you got 3 to 4 open-ended. Okay, so this is something, your test 3 is next week. And as usual, you got 24 hours to do it. Then you just submit back to me like what you guys did last time. And then your project, I will postpone your project. I think there are 2 or 3 students already submit your project to me. I did go through it and I replied back to them. They are missing something else. They should able to finish up. So if you have your project done this week, you want me to go check your project, you can send the project to me, and then I will tell you what's going on, because there are some students send the project to me already. I can figure out. So for your project, your due date is not on Tuesday because you got so many things due on Tuesday. You got your homework due on Tuesday. You got a test that is due on Wednesday. So your project in this case will be due on Thursday, the May 7th. Okay, so your project is due on Thursday, May 7th. How do you submit your project? Send an email to me. What kind of format you want? You can put in Words, you can put in PDF, you can put in PowerPoint, you can put in any form as long as I can open in my computer. So those people who are using Apple or Mac computer, make sure that you send it to me and make sure I can open it. And usually if I can open it, I will send a reply back to you that, you know what, I got your project, I'm able to read it. But if I cannot open it or I cannot do anything because it's a different document that I don't have, I will send an email back to you, say, I cannot open your file. Can you save it in PDF? Because PDF is kind of like a general, everyone can see it. So I will say, can you send it to me in PDF form so I can see your project? So please, when you guys send me a project, give me a few hours, I will reply back. If I didn't get reply back, if I didn't reply back to you means I didn't get the project. If I reply back to you, say, yes, I received a project, that means good, you're good to go. If I reply back, say, I cannot open your file, make sure you send it to me in PDF. So in other words, just send it to me in PDF form because that'll be easier to do. Microsoft, I have Microsoft Words. I don't know what happens to my Microsoft Words today. Something happens to it, I cannot open. But that is what's going on in test 3. Now we're talking about your finals. So your final in this case will be on Monday, May 11th. So 2 Mondays, not this coming Monday, but the following Monday, your finals will be. Your final will consist of chapter 1 to chapter 12, except 4. So your finals will consist of chapter 1 to chapter 12. So everything you learn in my class from the first day till chapter 12, the last day, which is next week. And then we didn't cover chapter 4, so chapter 4 is not included. Your final is all 50 multiple choice question. So your finals do not have open-ended questions like your previous tests that you have. Your test 3 has open-ended question, but your final is all 50 multiple choice question. So you got 24 hours to do it. As usual, you got 24 hours. So that means it will due on Tuesday, May 12th. When you guys do the multiple choice question, I would recommend you to just use something like a notepad or something else like that, like here. And then you just, or any Word document or anything, you just type your name. This is your pledge first, your pledge. And then after that, and then use your name and so on, right? This is how you do it. And then you just say question 1 is A, question 2 is B, question 3 is E, something like that. Okay, you do not need to show me work. You do not need to show me anything. I just want you to give your answer as A, B, C, D, E. And you only got one answer. You cannot have 2 answers. And then you just go all the way to 50. And then you just send this to me, and then I'll grade for you. So for your, because I have a lot of finals to grade, I got 150 students this semester. So so that's the reason why that I have really busy. You think I have nothing else to do? I am so busy right now that you have no idea. I'm great. I have to create 8 tests this week, 4 for test 3. I got 4 classes and 4 for finals. So I'm doing a lot of work here. So I want you, so what you guys do in my final is very easy. It's just put your pledge down, put your name down. This is the final for 1210, and then you just put down your A, B, C, D. Number 1, A, 2. You do not need to show me work, anything, any R. You do not need. If you want, you can do it your own, but this is what you have to send it to me. And once you send it to me, I will grade this and then return back to you because I want to make things easier for me for finals, because I have to grade your project also on top of your finals and all your tests. So make sure that you guys understand what I mean by this.
I think so.
Yeah, so make sure you guys do this. Also make your life a bit easier, make my life easier too. So anyone have any questions, and then you save it and then you send this to me. You do not understand the test paper or anything. You just send this to me. That's what I'm looking forward for it. Questions about your finals, your tests, your project. So some of you asked me about, I did really bad on my previous test. Will I do better? Will I get a passing grade in this class if I do well? The answer is yes, you can. Because if you look at the syllabus, your grade is just a very small part of your tests, right? Your first test, your test, okay? So let me show, you guys have my new syllabus, right?
Maybe not.
Go to, let me see. It's in D2R, right?
You might have kicked me out. I was open in there. Yeah, I'm still open here.
Yeah, I should be open. I do not kick everyone out. So go to the syllabus. You should have the latest syllabus that I posted. I think you guys have it, right? I sent it to you on the when after the spring break, I sent you the new one.
Oh,
so it will be so it's all over there. So you're still able to get quite a lot of points back for the test 3, your project, and your final, because you got 3 missing big chunk of your points. So even though you bombed the second test that you did, you're still able to do well in this test, in this class, if you do well on those tests and your project. Usually, I think I told you the project, the mean of the project is like 80 something, so 80 some percent. So the test, the normal test is only 15%, and your project is also 15%. Your final is 20%. So with test 3, 15%, your project is 15. That's 30. Final is 20, 50. You still have 50% left in this class that is not been accounted for.
Cool, thank you.
So for next week, you will have test 3, you have your project, and then the following week you got your final. So you still have 50%. So if you do bad in your test 3, you won't get an A, I can tell you that. If you completely bomb test 2, the previous test, then you won't get an A in the class. You probably will get a C or a B, depends on how well you're doing. And don't forget, your online hold rate is at 20%. So it will give you points in this case. So I want you to point out to you that if you bomb one test, make sure that you do really well on the last test and your finals and your project. Then you probably will earn either a B or a C, depends on it. But if you bomb your test 3 and test 2, then I can tell you your grade will be either D or F, because it's 30% gone. Because each test is 15. So if you bomb 2 tests, so say goodbye to 30%. So you get either D or F. So that's why that I want you guys to know that you can still get a C in the class if you bomb the last test, but make sure you do well in this test, because I can tell you that this test 3, is very short, because 10.1, chapter 10, you got 2 sections, chapter 11, you got 2 sections, and chapter 12, you got 2 sections. So this test 3 is only got 6 sections, 3 chapters, 6 sections. But I can tell you that the very last section, 12.2, is very, very difficult. It has a lot of work on it. You have to do a lot of work in chapter 12, actually. So, so make sure you guys come to my Zoom meeting next Monday, where we go over chapter 12. Then your finals is multiple choice. You got 50 question multiple choice, and it's 20% of it. So make sure you guys, do well on the. Okay. So anyone have any questions for me before we end this Zoom section here?
I do on the project. I just sent you an email. I know you asked me not to. I had my thing on.
All right, before we talk about project, wait for a minute. Anyone have any other questions that is related to something else besides project? Because Greg has his own, I'm not recording anything here. So, okay, if you don't have any questions, if you have questions, you can stay. I'm going to stop recording here. So I don't want to